So evaluating is just a fancy word for solve. So what we're going to do here is evaluate the function y is equal to 2x plus 3 for the following inputs. And we're going to make a table here. What's up?
Can I get an eraser, please?
Yes. Can you get an eraser, you said?
Yes.
Yeah. So we got y is equal to 2x plus 3. So this is what our tables are going to look like here. We've got our inputs on the left. Those are my x values. I'm going to solve my function out in the middle and get some value for y as an output. And then I'm going to have my answer be the ordered pair of our input combined with our output. I know it looks like a lot, but once we get into it, it won't be too bad. My first input here is going to be 0. So we're going to take this equation, y is equal to 2 times 0 plus 3. We just plug the x value in for x. Right, 2x plus 3 becomes 2 times 0 plus 3. What is 2 times 0? 0 plus 3. 0 plus 3 gives me 3. So with an input of 0, we work that equation out, that function out here in the middle, and we get an output of 3. So my ordered pair here is going to be what? 0, 3. Not too bad, right? Like I said, we've been doing this just in a different kind of different way. Next, let's say we've got an input of 1. We're going to do that same process over again. Y is equal to 2 times 1 plus 3. What does 2 times 1 give me? 2. Plus 3 gives me 5. Boom. There's my output. Exciting stuff, I know. What's my ordered pair going to be here? 1, comma 5. Let's do an input of 2, see what we get as an output. Y is equal to 2 times 2 plus 3. Again, we're just plugging that input in for x. What would 2 times 2 give me here?
4.
4.
Plus 3 is 6.
4 plus 3?
Oh, wait, no, 7.
7. There we go. So my ordered pair is going to be 2, comma 7. Give me a thumbs up if this is making sense so far. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. 15's not bad. Let's get the other 12 of us there somehow. And our last input here, let's say we got 3. We're going to input that 3. 2 times 3 plus 3 is what our function looks like. What would 2 times 3 give me? 6. 6 plus 3 gives me 9. So my ordered pair here is going to be what?
2,
3, comma 9.
Oh, I see the pattern.
Good. Take a look at these ordered pairs here for a second. Do we have any repeating inputs at all?
No.
No. If I had plugged in 0 to this function down here at the bottom, right, I'd have a repeating input. But what would I get if I plugged in 0 as an output?
3.
3. So I'd get the same input with the same output. That's fine. But if we had somehow, or for some reason, plugged in 0 and got a different output, that's when we would not have a function. But because each of these inputs has exactly one unique output, this is a function. And we can tell that we're adding what to each y value from point to point? 2. What was the slope of this line that we have? mx plus b, what's my m? Look back at the equation. What number is in front of x?
2.
2. So if my slope is 2, my change in y will be plus 2
Plus 2.
over my change in x, which is plus 1. Right? So everything we were learning is connected. Now, we talked yesterday about describing functions. We're going to end that table there. Yesterday we talked about describing functions with these 4 terms: proportional, non-proportional, linear, and non-linear. So is this function here proportional or non-proportional? Give me a thumbs up if you think it's proportional. Give me a thumbs down if you think it is non-proportional. Thumbs up for proportional, thumbs down for non-proportional. I've failed you all. This is non-proportional. Everyone had their thumbs up. Why is this non-proportional? Ida, why is this non-proportional? Because b is equal to 3. Take a look.
Oh, B has to be.
Proportional functions don't have a b on the end. If you see something being added or subtracted, right away we know it is non-proportional.
Oh, that's right.
Maybe I'm going to tell myself you guys were thinking about linear and non-linear with that one to make me feel better. This is non-proportional because b/c means because b is equal to 3, not 0. Non-proportional. Let's try the next one. Have a little bit more faith. Give me a thumbs up if you think this is linear. Thumbs down if you think it is non-linear. What do you think? See a lot less thumbs now. Don't be scared. It's all right to be wrong. Good. I see mostly thumbs up. This is linear. Let's take a look back at how to tell. Obviously, we don't have this graphed, so we can't compare the shapes of the lines. But linear functions have no exponents in the equation. As soon as you see this tiny little 2 on the top, we know that it's going to be nonlinear. But if we don't see that exponent, it's always going to be linear. So this is non-proportional, and this is linear. Oops, there it is. This is something we're going to have to do on worksheet 32 after we work out our table. We've got to describe the function that we see without graphing. Linear, because no exponents in the equation. Y is equal to 2x plus 3. Questions so far? Feeling okay? Not too bad? Just tired? Okay. Tomorrow's Friday. It'll be all right.
Tomorrow's Friday.
Thursday.
Thursday.
Do we have school on Friday, though?
No.
So tomorrow's Friday. Because it's the last day of the week.
What?
You don't get
It
it.
was a I get the week.
He doesn't get it.
I guess it.
Some of you get it.
I get it.
Yeah, basically tomorrow's Friday. Because we don't have to go to school the next day.
Yeah.
So it's our short Friday. All right. I mean, you can come to school on Friday. I just won't be here. So, yes, Ross. Yeah. All right, let's do one more because I want you guys to get right to work since we have less time today and the IXLs took.
Oh yeah.
IXLs were super short. This worksheet is probably going to take a little longer. That's all right. At least we don't have our project to worry about anymore. I'm going to make my table a little bit bigger here. I didn't like how cramped it was. Let's do y is equal to x squared plus 1. And our first input is going to be -2.
Wait.
So our input here, our first input is -2. We're going to take our equation and substitute out the x for this first x value. Y is equal to -2 squared plus 1. Now, when we say -2 squared, what are we doing there?
-2 times -2.
-2 times -2, right? Not -2 times 2. It's -2 times itself 2 times. Down here I can -2 squared is equal to negative 2 times negative 2.
Rewrite that.
You don't have to, if you understand it. What is negative 2 times negative 2? Positive 4, because a negative times a negative always gives us what? A positive, okay? So negative 2 squared gives me 4. Any questions on how we got 4? I know it looks like we just did 2 times 2. It's a little bit different than that. What does 4 plus 1 give us as an output? 5. So my ordered pair here for the first one is going to be what? Negative 2, comma, 5. This is where things get a little bit tricky because we got that exponent. So I want to make sure we're understanding as we go through. Let's plug in a negative 1. Y is equal to negative 1 squared plus 1. What is negative 1 squared? Negative 1 times,
Positive?
not 2. Just said it's not 2.
Positive?
So it's negative 1 times negative 1, which gives us
Positive.
1. Positive 1, right? 1 times 1 is 1.
Positive 1.
Yeah, a negative times a negative gives us positive. Everyone should know this. What is 1 plus 1?
2.
2. There we go. So we've got negative 1, comma, 2. Let's plug in a 0 and see what happens. See if we've got a, if we're going through the origin. So we plug in a 0, we get y is equal to 0 squared plus 1. 0 squared, which is just 0 times 0, gives us what?
0.
0. Plus 1
1.
gives me 1. So my ordered pair here of input comma output is 0 comma 1. What about an input of positive 1? We get y is equal to 1 squared plus 1. What is 1 squared equal to?
1.
1 plus 1 gives me
2.
2.
Wait.
What do we notice about that output? Anything interesting? Devin, what do you notice?
There's 2 repeating numbers.
There's repeating numbers, right? But what number is repeating? An input or an output? Output. Is that okay?
Yes.
Yes, it is. We cannot have repeating inputs, but we can have repeating outputs. Last one, let's input a positive 2. Sorry, my last solution there was 1 comma 2. If we input a positive 2, we got y is equal to 2 squared plus 1. What does 2 squared give us?
4.
4. 4 plus 1 gives me
5.
5. What do we notice about that output?
There's 2.
There's 2 of them. So we got double 5s, we got double 2s. Look at this. It's kind of like symmetrical, like a mirror. 5, 2, 1, 2, 5 for our outputs. Morning, Jared. So these 5 solutions here, these 5 ordered pairs, thank you, sir. If we were to graph them, here's what it would look like. Obviously, you guys don't have graphs, so don't worry about this. Let me show you. You will have to do this eventually, so make sure we're paying attention. This first point, -2, 5. I'm going to go -2 on the x, +5 on the y. Make my dot right there. Then I've got -1, 2. -1 up 2, make a dot. 0, 1. There's my y-intercept right there at 1. Does that look like a straight line to you?
No.
No. My 4th point, 1, 2. We go over 1, up 2. And finally, +2, +5, over 2, up to 5. Anyone remember what we call this shape here?
Backwards triangle.
A parabola. That's our little U-shaped graph we just found. The reason why this line kind of curves back up in the same way that we kind of came down on the left is because when we square a number, can we get a negative?
No.
Think about it. If we square a negative number, what kind of answer do we get? A positive. What if we square a positive number? What type of number do we get? A positive. So anytime you square your input, you're going to get a positive output, unless of course we're subtracting 10 or something like that. But that's why this shape kind of comes out the way it is. We'll go more into that later, but I just wanted you to see kind of what that would look like. So let's describe this function. Give me a thumbs up for, actually, yeah, give me, let's start with linear, nonlinear. Give me a thumbs up for linear, thumbs down for nonlinear. Remember, linear means a straight line. Give me a thumbs up. This is a straight line. Thumbs down if it is not a straight line. It helps that we just saw the graph, which was very obviously not a straight line, right? So this is non-linear. We could tell because there's exponents in the equation, right? X squared plus 1. Right away we know this is not a straight line. We can say that it forms a parabola when graphed.
Mr. Church, can I use the restroom, please?
Sure. Now, give me a thumbs up if you think this is proportional. Thumbs down if you think this is non-proportional. Thumbs up for proportional. Thumbs down for non-proportional. Only see a couple thumbs. Good, they're all down. How do we know this is non-proportional? Osase, how do we know? Because there's a negative input? That's a great guess. I totally see what you're saying there. But we could have a proportional relationship with negative inputs. But I love that. That's great. Vincent. Doesn't go through the origin. 0, 1. That's another great reason. Francisco? Bingo. That's the big reason, right? Vincent, you're totally right. Even if this was a straight line, if it goes through 1, it's non-proportional. But what do proportional relationships need to be?
Linear.
Linear. Even if this is a parabola that goes through the origin, it's non-proportional because it's not a straight line. Okay? So non-proportional relationships, like we said yesterday, could be linear or not. In this case, this is not linear and also non-proportional. So we could say not linear and not through the origin. So neither of those conditions are satisfied. We only need one of them to not be satisfied for this to be non-proportional, but 2 is even better. It's like how like a square is technically a rectangle, but a rectangle is not a square. You guys know what I'm talking about? A rectangle, because this is like kind of a interesting thing. If we have a square, right?
Yes. Okay.
What makes a square is that all 4 sides are equal lengths and all 4 corners are 90 degrees, right? But what makes a rectangle is that all 4 corners are 90 degrees. And the 2 opposite sides are equal, and the other 2 opposite sides are equal with a different number. Technically, a square satisfies all the conditions of a rectangle, right? These opposite sides are equal, these opposite sides are equal, and all 4 corners are 90 degrees. But a rectangle does not satisfy the conditions of a square because not all 4 sides are equal lengths. Do you guys know what I'm saying by that?
Yeah.
Good. Some of you are like, why are we talking about squares? That's fine. This is kind of like a very general math idea and something that, I see in life all the time. Well, never mind. We're not going to go too deep into it. But hopefully you get what I'm saying. Right here? Yep. I'm going to leave that there while we get worksheet 32. We can get started right on this. We got a good 15 minutes to get started and ask any questions that you might have.
Actually, 18.
What is going on?
Actually, it's 18. It's a balloon.
Thanks, sir.
You haven't made yourself yet.
Isn't it beautiful? No, not the goldfish, the balloon. The balloon. Like,
Here you go.
yeah, this is.
So let's take a look at number 1 real quick. So you guys are already off to the races, which is great. But for those of us that need a little bit of a jump start, number 1 is halfway done for us.
Is this due tomorrow?